Hi everyone, today we're going to study applications of trigonometry that involves right triangle. First, let us define angle of elevation and angle of depression. The figure here will help us understand the angle of elevation and angle of depression. Here we have a tower, and we assume that there are two persons present in the figure. One is on the ground, and the other person is on top of the tower. And eventually, they are looking at one another. The person on the ground will look up to the person on top of the tower, and he is making an angle of elevation. Meanwhile, that person on top of the tower will look down and see the person on the ground. Upon looking, he is making an angle of depression. Take note, this angle here is the angle of elevation, and the angle here is the angle of depression. Now, let us have the formal definition. The angle of elevation of an object above an observer relative to the observer is the angle between the horizontal and the line from the object to the observer's eye. The angle of depression of an object below an observer relative to the observer is the angle between the horizontal and the line from the object to the observer's eye. One important relationship of the angle of depression and the angle of elevation, they are equal. We have steps to follow in solving applications of trigonometry. Step 1. Read the problem carefully. Step 2. Draw an appropriate diagram. And step 3. Solve the required value using appropriate trigonometric formulas. Let us have example 1. To find the height of a tree, a person walks to a point 30 feet from the base of the tree. She measures an angle of 60 degrees between a line of sight to the top of the tree and the ground, as shown in figure. Find the height of the tree. Given here are the values for sine 60 degrees, cosine 60 degrees, and tangent 60 degrees. To illustrate the problem, we have the figure here. The tree is standing tall, and there is a person at this point 30 feet from the base of the tree. The angle of elevation of that person to the top of the tree is 60 degrees. And we are required to find the height of the tree. In relation to the right triangle, the height of the tree corresponds to the opposite side of the angle. And this 30 feet here corresponds to the adjacent side. It means we need to use the tangent ratio, which is equal to opposite over adjacent. Substituting the values, we have tangent 60 degrees equals the opposite, which is the height, over the adjacent side, and that is 30 feet. Simplifying this equation, we will cross multiply the 30 to the left side. So we have now 30 times the tangent 60 degrees. And that is equal to the height. Then tangent 60 degrees is equal to the square root of 3. And the height now is 30 square root of 3 feet. We don't forget to affix the unit of measurement. And this is our final answer. Let's have example 2. A radio tower is located 400 feet from a building. From a window in the building, a person determines that the angle of elevation to the top of the tower is 45 degrees and that the angle of depression to the bottom of the tower is 30 degrees. How tall is the tower? So we have this figure here to help us solve the problem. We let this line AB be the radio tower, where A is the base and B is the top. We let this W be the window in the building. Then we will draw a line WD perpendicular to AB. So the height of the tower is AB, and AB is equal to the AD plus the BD. In the problem it says, from this window, the angle of elevation is 45 degrees to the top, and also from the window, the angle of depression to the bottom of the radio tower is 30 degrees. And the distance from this window of the building up to the radio tower is the 400 feet. You can see now in our figure that we have two right triangles here. The first triangle is BWD. The other triangle is ADW. In the figure, we are going to compute AD and BD separately using separate triangles. Let's start computing for BD. We're going to use the triangle BWD. To compute for the BD, that is the opposite side of the angle 45 degrees. And the side here with 400 length is the adjacent side of the angle 45. So we're going to use tangent ratio, which is equal to opposite over adjacent. Substituting the values, we have tangent 45 degrees equals the BD over the adjacent side, which is 400. Simplifying further, tangent 45 degrees is equal to 1 equals the right side still BD over 400. We will cross multiply 400 to the left side. We have now BD equals 400, and we will affix the unit of measurement, feet. So the BD is 400 feet. Now let us compute for the length AD. using the triangle ADW. The AD corresponds to the opposite side of the angle 30 degrees. And again, this 400 is the adjacent side of the angle 30 degrees. Substituting now the values for the tangent relation. Simplifying further, the tangent 30 degrees is equal to 1 over the square root of 3 equals the AD over 400. Now this 400 will be cross multiplied to number 1 on the left side. We have now AD equals 400 over the square root of 3 feet. We have now the values AD and BD. We're going to get the sum to get the final answer of AB, which is the height of the tower. So AB equals the AD, which is 400 over the square root of 3 plus the BD, that is 400. To simplify further, we will just take the common factor of 400. What remains here is 1 over the square root of 3, and on the next term plus 1. Then we affix the unit of measurement, feet. So the height of the tower is 400 times the quantity 1 over the square root of 3 plus 1 feet. This is our final answer. Example 3. An electrician has to repair an electric fault on a pole of height 5 meters. He needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. What should be the length of the ladder that he should use, which, when inclined at an angle of 60 degrees to the horizontal, would enable him to reach the required position? To understand this problem, let us use this diagram. The AC is equal to the 5 meters. That is the height of the pole. Next is the AB. This is the 1.3 meter. Then the BC is AC minus AB. And that will be 5 minus 1.3. That is 3.7 meters. The angle D, which is 60 degrees, is given. Now, BD is the length of the ladder, and that is what we want to know. Using our diagram, we can see that the sine 60 degrees is equal to opposite over hypotenuse. Getting the values from the figure, we have this is 3.7, that is the opposite, over BD. When we substitute the value of sine 60 degrees, that is square root of 3 over 2 equals the right side 3.7 over BD. Let us cross multiply and get the value of BD. So that will be 3.7 times 2 all over square root of 3. When we simplify this, we have 4.27 meters. This is the length of the ladder. Example 4. An observer 1.5 meters tall is 28.5 meters away from a chimney. The angle of elevation of the top of the chimney from her eyes is 45 degrees. What is the height of the chimney? Let us use this diagram. The DE is the height of observer, and that is 1.5 as given in the problem. Note that this DE is equal to the BC. Then we have the BD. Given in the problem, this is 28.5 meters. Take note that the angle D is also given as 45 degrees. Then the AC. This is the height of the chimney. And this is what we want to know. In the figure, note that AC equals AB plus BC. Now, in the triangle ABD, we have this tangent 45 degrees equals AB over BD. That is opposite over adjacent. When we simplify this equation, this tangent 45 degrees is 1 equals the BD is 28.5. When we cross multiply, we will get the value of AB, and that will be 28.5. Then we will get the AC. That is the height of the chimney. That is AB plus BC. We have this value of AB here, 28.5 plus the BC, and this is the 1.5. So total is 30 meters. This is the height of the chimney. Example 5. The shadow of a tower standing on a level ground is found to be 40 meters longer when the sun's altitude is 30 degrees than when it is 60 degrees. Find the height of the tower. Let us use this diagram to illustrate our problem. Note that the BD is equal to BC plus 40 meters. The AB, that is the height of the tower, and that is what we want. Look here that in triangle ABC, the tangent 60 degrees equals opposite over adjacent. That is AB over BC. When we substitute the value for this tangent 60 degrees, that is square root of 3. When we cross multiply, we will get the value of AB, and that will be square root of 3 times the length BC. This is equation 1. Then in triangle ABD, the tangent 30 degrees equals opposite over adjacent. So that is AB over BC plus 40. The value of tangent 30 degrees is 1 over square root of 3. When we cross multiply, we will get the value of AB, and that will be BC plus 40 all over square root of 3. This is equation 2. And from here, we will equate AB values for equations 1 and 2. So it will be like this. Square root of 3 times BC equals BC plus 40 all over square root of 3. When we cross multiply, this square root of 3 multiplied by square root of 3 will be 3. So that will be 3 BC equals BC plus 40. This length BC we transpose to the left. So it becomes negative BC, and the left side becomes 2 BC. We divide the equation by 2, so the length of BC equals 20. Now, we're going to use equation 1 to get the value of AB, because this AB is what we want, the height of tower. So AB equals 20 square root of 3, then the unit of measurement is meters. This is our answer.